Welcome to Plant-Based Diets, What the Science Says. Dr. Constance Lee is the founder of the Medical Vegetarian Society and Just My Doc, which is a private telehealth practice which provides patients with direct access to physicians. In her talk, so she will go over the scientific research behind plant-based diets and their effects on chronic diseases like cancer, cardiovascular disease, high blood pressure, and diabetes. She'll also review some of the pitfalls to avoid with plant-based diets, such as some micronutrient deficiencies and how to make sure you get a complete protein profile. So please give a warm welcome to Dr. Constance Lee. Thank you.
Thank you so much, Brittany, and thank you all for being here today. Just a little bit more background about me. When I was in the Vegetarian Society in medical school, we started an organic garden on school grounds and gave away healthy food to the community. After I graduated residency in physical medicine and rehabilitation, I went on to found my own private practice called Just My Doc, based in Philadelphia. Not a lot of people know what physical medicine and rehab is, so I'll give you a little bit of an overview. I see patients who have had strokes, amputations, brain injuries, spinal cord injuries, and any kind of issue concerning their muscles, nerves, and connective tissues. So usually patients come to me after major medical illnesses or injuries, and I help them to function better again in as comfortable of a way as possible to improve their quality of life. And I've seen the downstream effects of many chronic diseases, which I'll be discussing today. Reviewing the strongest evidence about plant-based diets and their effect on cardiovascular disease, diabetes, cancer, and then we're going to discuss the state of protein and fiber in the U.S. So apologies for our more international audience, but it is a concern about what's going on in the U.S. because the Western diet is spreading rapidly. We'll go over B12 as a common micronutrient deficiency in plant-based diets. And then if we have some time, we'll also go over common misconceptions about omega-3s. So we'll start off with cardiovascular disease. Cardio means heart. Vascular means blood vessels. This is a class of conditions that involves heart attacks and strokes, but it really affects every single part of the body. What we mean by cardiovascular disease usually is a buildup of plaques that contain cholesterol in our blood vessels. When the plaque builds up in the arteries to the heart, they can cause a heart attack. When they build up in the arteries that go to the brain, they can cause a stroke. And this can happen to any organ in the body. And this happens not just in old age, but it actually happens at a very early age. People as young as 20 have been found to have plaque buildup in their arteries. So the earlier we're able to address this process and nip it in the bud, the better off we'll be when we're older. And why should we care about this? It is actually the #1 killer in the US and responsible for 1/3 of deaths in America. And why does plaque build up in our arteries? Unfortunately, a lot of it has to do with genetics, but there are some modifiable risk factors, such as cholesterol level, that we have control over through diet and exercise. Who has ever heard of good cholesterol and bad cholesterol? All right, so quite a number of people. So who actually knows what this means? Dr. G and a couple of people in the audience. All right, so we'll go over the basics here. Cholesterol is a very diverse group of molecules. Some types are beneficial, whereas other types can be damaging. Commonly, the shorthand bad cholesterol is also known as LDL, or low-density lipoprotein. And this comes from the liver and delivers cholesterol to the rest of our body. This is helpful because we need cholesterol for all of our organs to function properly. When it becomes damaging is when the LDL becomes too high and then it starts depositing cholesterol into our blood vessels to cause plaque. You can think of these like dust bunnies over there that go around and clog our arteries, whereas the Good cholesterol refers to something called HDL, high-density lipoprotein, and these are actually helpful in removing the LDL from our arteries and returning it back to the liver. So you can think of these as the vacuum cleaners that remove the dust bunnies. So there's a lot of different factors that influence your levels of good and bad cholesterol. Generally, the biggest controllable risk factor for raising bad cholesterol is diet. Eating lots of saturated fat and cholesterol while having low fiber is going to raise bad cholesterol. This is opposed to the biggest influence on good cholesterol, which is getting lots of exercise. The levels of each kind of cholesterol are managed by the liver, which processes all the dietary fat and cholesterol that we eat. A good mnemonic is that you generally want your LDL to be low and your HDL to be high. All right, so now that we've established that cardiovascular disease is very important and we have a handle on how it develops, let's look at the research. Overall, it's difficult to study the connection between diet and chronic diseases because it's hard to control exactly what people eat, so we have to rely on self-reports, which increases the chance of inaccuracy. Also, these chronic diseases take a very long time to develop, and so how we mitigate these difficulties in researching diet on chronic diseases is that we get research studies that have a lot of participants, and we follow them for a very long period of time. Harvard ran such a study to evaluate the effects of meat consumption on cardiovascular disease. They followed over 120,000 people over 22 to 28 years. Over this time, they gathered 24,000 data points on people passing away and were able to compare their cause of death with their reported diet. The results showed that eating red meat, whether processed or unprocessed, significantly increased the risk of death from cardiovascular disease. This effect was even more pronounced for other causes like cancer. So the first blue bar you see on the right is a baseline for the risk of death of a person who ate no red meat throughout the study. And as soon as people ate just one serving of unprocessed red meat a day or more, their risk of dying from a heart attack or a stroke jumped up 18%, as shown by the red bar. If this serving was actually processed red meat like ham or hot dogs, this jumped another 3 percentage points. All right, next we'll cover the evidence for diabetes. And again, we'll start off with the basics. So who's heard of type 1 and type 2 diabetes? Great, a lot of people. And who knows what the difference is? Okay, less people. Diabetes is all surrounding a little hormone called insulin, which is produced in our pancreas and is responsible for moving all the sugar or glucose in our blood into our cells where it can be metabolized into energy. In type 1 diabetes, the main issue is that we're not producing enough insulin. This is often called juvenile diabetes and is mainly caused by genetics or a viral infection which damages the pancreas. So these people usually have to supplement with insulin, usually have to give themselves injections, and this starts at quite a young age. On the other hand, type 2 diabetes is actually resistance to insulin. Our cells, even though they're getting plenty of insulin attached to their receptors, they're not able to respond to it. Usually this is adult onset, so it happens later in life and is dependent on a number of lifestyle factors, and in the medical community, we generally correlate obesity with the development of type 2 diabetes as its number one risk factor. And these people may or may not be insulin dependent. They can take medications which increase their cells' response to insulin a lot of the time, but if it progresses, eventually they do burn out their pancreas and then become insulin dependent. So how concerned should we be about diabetes? Here's some background epidemiology for the US so we can account for how many people are affected. Currently, about 1 in 4 people have prediabetes and are likely to develop type 2 diabetes in their lifetime. And if the trend of rising levels of diabetes continues, it's predicted that 1 in 3 children born after the year 2000 will develop diabetes at some point. So why does this actually matter? Is it just to the extent that these people may have to take insulin and medications for the rest of their lives? Sure, they need to do that in order to regulate their blood sugars, and this can often feel like a game that they can never stop playing. And that's hard enough as it is, but what does it actually look like if they're bad at playing this game, and then they have to deal with years of accumulated damage from high blood sugars? So unfortunately, I see this in the hospital all the time, and it doesn't look pretty. Diabetes, while not a direct killer like heart attack or stroke, is still hugely important to our quality of life and the development of other chronic or deadly conditions. It can cause small vessel disease and inflammation throughout the body, which can lead to slow and devastating damage. Again, we can see the plaque development. It really accelerates development of plaque in the arteries, so it's actually a really big risk factor for the development of heart attacks and stroke and cardiovascular disease in the future. The retina in the eyes can start to get inflammation in their blood vessels, and the retina can hemorrhage, which can cause blindness in people that is slowly progressive and not reversible by eyeglasses. When it happens in the kidneys can get small and scarred and non-functional, and people can eventually become dependent on dialysis, where they have to go to a center to get hooked up to an external kidney 3 times a week, and this takes hours of time. This can also result in nerve damage, especially the nerves that are longer and further away from the body, so they don't get delivery of blood as easily. And this can result in something called neuropathy, where the nerves don't function and we get numbness and tingling that can be permanent. And finally, this is near and dear to my specialty. People can get really poor wound healing because they're not getting oxygen delivery to their feet and their hands. And when they get a small little cut, this can develop into a really bad ulcer. And it's even worse because they oftentimes can't feel their feet, so they don't even know when they're getting an injury. And over time, when these wounds don't heal, they can get infected, and then this leads to amputations. All right, so now that we know the prevalence and the potential devastation of diabetes, let's look at the research. We can look at the Adventist Health Study, which studied almost 100,000 Adventist church members. And this was a good population to study because a lot of them are vegans or vegetarians. So we have a good number of them in, and they have very similar lifestyle factors. So there's not too much variation to control for. They tracked these participants every 2 years on a whole range of health data. And these charts are arranged by the diets that are highest in animal products on the left in red, and then the diets that were lowest in animal products, the vegans, in blue. And it was found that as people had less animal products in their diet, they had lower BMI, which traditionally we correlate with a predisposition for diabetes. And then this is reflected well in the prevalence of diabetes, where as you ate less animal products, you're less likely to have developed diabetes. How do we actually say that this is not just correlated to body mass index? We said earlier that this was considered the biggest risk factor, but the statisticians in this study actually accounted for that. And so they did some fancy math and adjusted for a whole host of risk factors such as BMI, age, sex, ethnicity, and physical activity, and still they found that vegans were half as likely to develop diabetes compared to the non-vegetarians. So there seems to be some compelling evidence that there's either something about a plant-based diet that's protective against diabetes or something about animal products that predisposes one to diabetes. All right, next we're going to cover the evidence for plant-based diets and cancer risk. So for this, I relied off of the rigorous compilation of evidence compiled by the World Health Organization. Now, it takes a lot for the World Health Organization to give out recommendations and say that there's actually evidence for a connection between a risk factor and a disease. For this study, they considered over 800 different studies on cancer and diets, and they distilled this down to 10 studies that were the most rigorous and found that for every 50-gram portion of processed meat, the risk of colorectal cancer increases about 18%. So these are their official statements. So for red meat, which is like steak or pork, they found that it's probably carcinogenic to humans. And that's actually a very big statement from the World Health Organization. And it was most strongly correlated to colorectal cancer, which you can see right here. This is a colon that was opened up. On the left over here, you see nice normal colon tissue, and then on the right you can actually see this like angry lumpy red polyp, and that's cancer. That's what it looks like. There were also some evidence that showed that there was an association with red meat and pancreatic cancer and prostate cancer as well. Next, for processed meat, the evidence was even more damning, and they classified it as a carcinogen, meaning that it causes cancer. Again, this was mainly with colorectal cancer, but there was some evidence that the processed meat was also associated with stomach cancer. Yet with all this evidence, people are really still confused about why colorectal cancer is increasing in the United States as per capita meat consumption also increases. Now we're going to discuss something very popular in our society today, which is protein. Everybody always asks vegan and vegetarians, where do you get your protein from? Well, what is protein? This is protein. It's just a series of small molecules that can be linked together in various ways to produce almost anything that we need in our body. And what is actually the prevalence of protein deficiency in the US? So in medical school, we learned about something called kwashiorkor, which generally displays as someone who's really skinny with very low muscle and a big belly. This is because they don't have enough protein in their body to absorb the water back from their belly. So there's actually an osmotic difference. Now, in all the years that I've been in training in hospitals, I've never seen one case of this in the US. Contrary to all the hype that everyone needs more protein, most people in the US actually meet or exceed their needs for protein, which is especially true for males aged 19 to 59. Who are usually the ones that are most concerned about protein deficiency. Overall, about 10 to 35% of your calories should come from protein, and this changes depending on what stage of life you're in. So for the average sedentary adult, they only need 0.8 grams of protein per kilogram of body weight. Starting from the ages of 40 to 50, where it's more difficult to maintain your muscle mass, you'll actually have to increase this requirement to 1 to 1.2 grams. For people that are exercising all the time, this goes up to 1.1 to 1.5 grams. And finally, for those regular weightlifters who break down their muscle all the time to build it back up, they just need 1.2 to 1.7 grams of protein per kilogram of body weight. Also, a common misconception in the animal agriculture industry is that only animal products are complete sources of protein. I was taught this when I was a major in animal science back at Rutgers. And then I did some more research of my own, and I found that actually most beans, including soy, which is one of the biggest crops in the US, by volume, are complete sources of protein. And what does this mean? It just means that they contain good proportions of 9 of the essential amino acids that the human body needs, that they can't produce on its own. And so I took all this research and I went back to my professor and I was like, did you know about all of this? And he just scratched his head and he said, no, I've never heard about this. I guess I need to update my PowerPoints. And he had been teaching for decades. So the misinformation in the animal agriculture industry is strong. Also, why do we need to care about complete proteins? We only need to care about complete proteins if we're eating a single source of food for our entire lives. Like if we're only eating wheat or we're only eating corn and not eating burritos that package it all together. So most of us get all of our amino acids through complementary proteins, which is foods with various profiles of amino acids that come together to give us all the essentials that we need. Next is one of my favorite topics, which is fiber. Not as sexy as protein in the US, arguably much more important. Many health conditions have been linked to a low fiber diet, including constipation, irritable bowel syndrome, diverticulitis, heart disease, and some cancers, including colorectal cancer again. When I was in training in rehab, we used something called the Bristol stool scale, and you can see that in the middle. The nurses would look at the patient's stool every day and categorize them based on how hard and lumpy they were, which correlates with constipation, to how soft they were, which correlates with diarrhea. And we put this right next to heart rate, respiratory rate, temperature. It was the fifth vital sign to us, and it's something that many physicians have to manage in the hospital. And how do they manage it? They actually manage it by giving the patients more medication. So almost everybody that comes into the hospital gets put on a stool softener, which actually helps most people because they are constipated. But the occasional person that has enough fiber in their diet and is not constipated then gets diarrhea. Constipation is a huge issue in the US that we don't really like to talk about too much because we can fix it with medications. Whereas like if we just ate more fiber in our diet, that would bulk up our stool and regulate our bowel movements naturally. Not to mention, there's the whole concept of gut microbiology. So there's a lot of helpful bacteria that live inside our gut, while we ourselves cannot derive energy from fiber because it goes right through us. The bacteria actually like to feed on this, and then from the byproducts that they create, that can provide all sorts of benefits to human health that we don't quite understand yet. And then going back to the concept of cholesterol, usually fiber that exists in the gut can help absorb cholesterol that gets put out by the liver each time we eat a meal. So it can actually help to reduce cholesterol on top of everything. We'll go over micronutrient deficiencies that people on plant-based diets should look out for. I'm mainly going to focus on B12. B12 is an essential vitamin that's mostly found in animal products, but is always originally synthesized by bacteria or yeast. It's always kept in our livers, and we usually have enough to last us years. And so a common misconception among vegans and vegetarians is like, oh, maybe I just need to take a B12 supplement every couple of years, and then I'll be stocked up to go. Well, this is not actually true. Absorption levels can decrease with age. If we're not sure where we stand in our B12 levels, we can check quite easily using a blood test. Some statistics in the UK, where fortification with B12 is a little bit more rare, 50% of vegetarians and 75% of vegans were actually found to be deficient or depleted of B12. And why do we care about this? So there's the direct effect of B12 efficiency, where we can develop subacute combined degeneration, which is a neurological disorder which can cause pretty sudden numbness and tingling in the hands and feet, as well as muscle tightness. Oftentimes this can be a medical emergency. And it can also cause anemia, where the red blood cells don't develop properly, and so we're not getting good oxygen to our body. Also, this is a little bit high-level biochemistry. Having low B12 levels can lead to increased homocysteine levels, which is a molecule in the body that has been associated with increased risk of cardiovascular disease, diabetes, and dementia. So how do we fix this? Well, it seems pretty easy. We just supplement with some B12. There are many supplements available on the market. Some tips to follow is that you should make sure that your B12 is mixed with saliva first, so that it binds with a protein called intrinsic factor, so that we can actually absorb it. So the B12 pills, where you just pop it in and it goes into the stomach, not a lot of that can be absorbed, even if it's 10,000% of your normal B12 requirements. And then also there's two main types of B12 available on the market. There's cyanocobalamin and methylcobalamin, and it's often confusing which one we should take. Generally, the cyanocobalamin is more stable than the methylcobalamin and also tends to be cheaper. So I actually took this from Dr. Grieger's video. When given the choice, choose the cyanocobalamin and save yourself some money. Finally, we're going to go over omega-3s. So there's been many health articles published about how omega-3s will prevent dementia and give us all these other amazing health outcomes. And while it's true that omega-3s are found in many important tissues in our body, we actually have to look at the evidence. When I went to look at the Cochrane Library, which is the highest level of meta-analysis evidence collected in the US, they don't come up with studies on their own, but they collect studies that are created from all over, and they find the highest level ones, and then they distill it down and tell us what is found from it. For every single disease, it has never been shown that supplementing with omega-3 or having an omega-3 deficient diet is shown to increase or decrease the incidence of dementia, heart disease, stroke, or death. I combed the internet for evidence and I couldn't find any. And yet we're still talking about how essential omega-3s are. And there just seems to be a discrepancy there. There's 79 randomized studies involving 112,000 people that showed that this purported physiological mechanism of omega-3s helping our bodies doesn't really translate into real-world outcomes. Plus, on top of that, we have no way of knowing if we're deficient in omega-3s because there's no simple, reliable blood test for it. So that is my review of the science behind plant-based diets. We can open everything up for questions now.
Some raw vegans that ferment claim that they get B12 without supplementing. Could this be possible? I know it's not recommended, but I still want to know. And what does high B12 levels mean?
To answer the latter question first, there are cutoff ranges for B12, and they vary by country. I can't remember the actual numbers off the top of my head. Usually there's not an upper limit for B12 levels. I haven't heard of any B12 toxicity concerns. So it seems like as long as your tank is topped up, you're okay. As far as the fermentation, it depends on what they're fermenting. I mean, B12 comes from bacteria. So if they're fermenting and yeast, and so if they're fermenting with either of those things, they can have B12 in whatever they're eating, and it may not need to come from an external supplement.
Someone asks, the differences between a plant-based diet and a whole foods plant-based diet are extreme. Should we distinguish between the two when encouraging others towards veganism?
Oh, most definitely. I mean, a vegan diet can consist of just eating French fries all day long. And so the impact on animals with your diet can be equal between eating a very limited vegan diet versus a whole foods plant-based diet. In order to get the full spectrum of micronutrients and whole complement of amino acids, it is a good idea to eat a whole foods plant-based diet. Whole foods are less processed, so less of the fiber gets extracted from it. And as I went over, fiber is really important for gut health.
I like this question. How do we address people who say, if you must supplement your B12 with vitamins, maybe a vegan diet is not complete or natural?
I mean, we use technology to solve all sorts of issues in our life. Even the clothes that I'm wearing had to be synthesized somewhere. So at some point, we have to look at what is good for us now rather than what we've always been doing and what is natural.
Yeah. I guess a follow-up question just from me would be, are vegans the only community that suffers from a B12 deficiency or potentially could?
No, actually. There is there are other medical conditions that can actually predispose people to B12 deficiencies. One is called pernicious anemia. It's an autoimmune disease that targets the receptors for the intrinsic factor that I talked about that's secreted in the saliva. And in that case, people can't absorb B12 because it's not packaged correctly. And then there's also conditions that can affect your gut. So B12 is mainly absorbed in the latter part of the small intestine. So diseases that affect that, like Crohn's disease, can actually inhibit the absorption of B12, and they can have vitamin B12 deficiencies as well. Oh, also, as I said earlier, the older you get, it's more and more difficult to absorb B12. So a lot of older adults regularly have to have their B12 levels tested. And in fact, when I was doing my geriatrics rotation in medical school, almost every person over the age of 75 got a B12 shot once a year. Yeah.
So it sounds like a lot of people.
Many people.
Okay, so this is getting a lot of upvotes. When will research-based nutrition be taken seriously in medical schools?
The answer is I don't know. When I was a medical student, I actually did a presentation on this very thing. I did intern with Nutrition Facts and Physicians Committee for Responsible Medicine my first summer of medical school, and I was like, wow, this is so fascinating. Like, we can prevent so many chronic diseases with proper nutrition, and I was so excited to bring it back to my school, and I told all my fellow students, and they were like, yeah, it sounds like a great idea. And I said, well, can we develop like a lecture or a curriculum about this? And then they were all like, no, that's a bad idea. We're too busy. There's too much to learn as it is. So the medical school curriculum is very crowded with requirements as it is. And unfortunately, that's been a big hurdle.
Some of us have high cholesterol even on a whole foods vegan diet, and even with regular aerobic and strength training exercises. Why is this so, and what can we do about it?
Unfortunately, the levels of our cholesterol is mainly influenced by genetics. The diet and exercise are the modifiable risk factors that we're able to control, but it's hard to shake the genes that we are given by our parents. And so some people have predisposition to high cholesterol, which can be partly modified by diet and exercise. And if that's not enough to get them below the recommended level of LDL, which is 100, then they can take a pharmaceutical medication called a statin. Now, statins actually have a really good evidence base behind them, and many people are on them. And not only do they reduce levels of bad cholesterol in our body, but they can actually also reduce inflammation, which is a big driver in the development of plaques in our blood vessels.
What are some suggestions on how to achieve proper vegan nutrition for someone on the go? I'd love some recommendations on healthy meals or snacks that don't require much prep.
A lot of granola bars are great because the oats have a lot of fiber in them. You can actually see them, so they are whole foods, plant-based. When I'm camping, I really like to have like a can of beans that I don't need to hydrate and cook. It's already cooked for me. There's just a huge range of options out there. A good principle to follow by is to pick foods where you can actually like see the original like composition of it. So with like the oats and granola, and also eat a nice colorful palette like this image I have right here. The colors are usually correlated with the different micronutrients that the foods contain.
Can you define inflammation, and can fiber reduce inflammation?
Ooh, that's a question that actually will take a long time to answer.
I have time.
Yeah. So inflammation generally points to composition of like different molecules that are secreted by our immune system that tells our body to increase blood flow to a certain area, and also to draw white blood cells, which are part of the immune system, to that area. And it tells the body, there's an issue here. We need to address it. Sometimes inflammation can be good, actually, because it can clear out dead cells and clear the way for like new cells to be put down. But if it's out of control, it can cause a lot of destruction to the normal healthy tissues in our body.
Please give a giant hand for Dr. Constance Lee. Thank you so much.
Thank you.